Okay, this is homework 4. Let's go through these problems. So number 1, D&D players know very well that dice come in different varieties. One particular type is a 4-sided polyhedron called a tetrahedron. Imagine that each face is equally likely to land face down and that you roll the die 3 times. On each roll, consider only whether a 1 lands face down or doesn't. So you're going to roll the die, take a look at the bottom. If there's a 1 on the bottom, then you have a success. If there's not a 1 on the bottom, it's going to be a failure. That's what that means. All right, identify the sample space for a single roll. Well, the die has 4 sides. So the numbers on the dice are going to be 1, 2, 3, and 4. Those are the only possibilities. You can't roll a 7. You can't roll a 2.5. These are the only things that you can roll. Part B, let x be the number of times a 1 lands face down in 3 rolls. Identify the sample space for x. So we're going to roll 3 times and let x equal the number of 1s observed. Well, we're going to do something 3 times. A success is when we see a 1. The most successes we can have is 3. The fewest successes we can have is 0. You could roll 3 dice or roll a die 3 times and not see a 1. And the other possibilities are 1 and 2. There's no other things. You can't get 7. You can't get pi. You can't get -4. So the only values for the sample space for x. Now let's, instead of doing this, let's just write x because we're going to refer to it as x. These are the only possibilities you can have. Construct, for part C, construct the probability distribution for x, and I've noted use the Binompdf. So it's a binomial. We need 3 things. We need n, that's the number of trials. Well, that is 3. We're going to roll it 3 times. P is the probability of success. Well, that's 1 in 4, or 0.25. There's 4 equally likely. So we're told up here, each face is equally likely to land face down. That means our probability of success is 1 out of the total number, which is 4. So now we're going to create our distribution here. So we have 0, 1, 2, and 3 as our possibilities. We're going to use the Binompdf. So our x values will be our r or k, however you want to look at it. So the binom is seconds and vars. Scroll either way down or up. Binompdf is A on this calculator. Hit enter. And I don't have the display wizard up, but it'll typically ask you for the trials, P, and what your X value is going to be. Here we're going to have to plug them in. So our N is 3. We put a comma, which is above the 7. Our probability, you can put in 1 over 4. I'm going to put 0.25 because there's no rounding. If you had 1 over 3, you should really put 1 over 3 and not 0.33. And finally, our first x is 0. So that's 0.421. I guess we can probably just stop there. So round up to 0.422. That's binom PDF of 3.25 and 0. And we're going to do the same thing for the rest, only we're going to change this to 1, this to 2, and this to 3. Everything else will be the same. In fact, let me give you a quick way to do these, and we'll just we'll do them all at once. So stat and edit. I'm going to clear out this list too, and I need to clear out the 4. I'm going to put in my different different x values. 0, 1, 2, 3 are all that's possible. So if you highlight the L2, I put the cursor on the L2 itself, and run the binom. So second vars, Binompdf, our n is 3, comma, probability is 0.25, comma, and then we're going to list 1 as our x value. So second and 1, it's going to take the value from list 1 and plug it in as our third result. So it'll fill in the whole column. Please note that our first one is at 0.4218 and so forth. That's what we got. These others we can fill in as well. So 0.141 and then 0.016. Try to get this, 3 decimals or at least 2 sig figs if it goes beyond 3 decimals. All right. Part D, using this probability distribution. So I'm using what I've just created in part C. So this up here. Determine the probability of rolling at least 2 ones face down. So at least is greater than or equal to. So I want probability that x is greater than or equal to 2. Well, that equals probability that x equals 2 plus the probability that x equals 3. You could also run the binomial for this if you wanted to, but this one specifically says use your distribution. So that's 0.141 plus 0.016, which I think that's 0.157. Probability of rolling at most 2 ones. At most is that many or fewer. We can do these and just add them up, or we can do binom CDF of 3.25 and 2. So let's do that. Let's quit out of this. Second vars. We want the binom CDF with C is cumulative, so it's going to add all of those up. So 3, comma, 0.25, and finally 2. So 0.984 is our answer. And again, if you just added these 3 up here that I'm putting the red box around, that should get you there as well. All right, number 2. Uncover Credit Card has determined if a customer visits the company's website that there's a 30% chance the customer will register for a new Platinum VAT card. It also believes 10% of its customers who receive the flyer in the mail will eventually enroll. We want X to be the number of customers who apply for a new card. All right, so we have to note that this is a binomial. We have a chance for success for, let's just look at website. I think the first ones we want, website. So we're going to look at website here. So P for this is 0.3 from here. They're going to be independent because they've just got the general probability for anybody who goes there. One person who visits, it should be independent of any other person who visits there, so we have independence. N is 2 customers. So we want a distribution. So you can use the multiplicative rule to find out the probability x is 0 or x is 2. I'm going to use the binomial. So for the probability that x equals 0, I'm going to use the binom, PDF. 2 is our n, 0.3 is our p, and 0 is our x. Let's do that real quick. That comes out to 0.49. And coincidentally, that will be 0.7 squared. All right, probability that x equals 1, binom PDF, 2.3 and 1. I'm not going to do it on the calculator. I do have the answer here. It's going to be about 0.42. And then we have probability that x equals 2 is binom PDF 2, excuse me, 0.3 and 2. And that should equal 0.09. So they want a distribution. So I'm going to write the distribution here, the x values and the p of x. X could be 0, 1, or 2. And then we get 0.49, 0.42, and 0.09. All of this is the answer to part A. So again, we had two customers. We're calling a success whether or not they get the that card. And we have a probability of a success with 0.3. Part B, we do the same thing. Here, n is equal, let me space this a little bit apart. N is 0.1, excuse me, n is 2, p is 0.1. We're going to use the Binompdf PDF in the same manner, only we're going to change the p. I'm going to go to the calculator here. Go back in here. I'm going to remove this 3. And then I'm going to delete all of these by hitting clear and enter. Don't use delete for that. Highlighting L2, and I'll run the binom for all of them. Second bars, PDF. We have 2.1 and then L1 again. So our value should be 0.81, 0.18, and then 0.01. And that's our distribution. Again, you have two people. The only possibilities are 0, 1, and 2 for the number of successes, and then use the binomial. Let's see. Part C. If we select 12 customers who visit the website, what's probably at least one of them will sign up for the new card? So here we have a new one. We're not using the above distribution. We're using n is 12. The website, so p is equal to 0.3. That was given. And we want probability that x is greater than or equal to 1. Well, if you recall from the videos, in order to do this, we're going to take the complement, 1 minus the probability that x is less than or equal to 1 minus 1, which is 0, which is 1 minus the binom CDF, or PDF because it's 0, they're the same, 12.3 and 0, and that comes out to whatever I posted online. And then we have D. Let's see, we have 10 customers who receive the weekly flyer. What's the probability at most 9? So the flyer has n. First of all, n is 10, given. P is 0.1 for the flyer. At most is that many or less, so x less than or equal to 9. That's just a CDF. So 10 is our new n, 0.1 and 9. 0.1 because we changed from the website to the flyer, and that's like 0.999 repeating or 1. And number 3 was not on your homework, so we're going to go with just this.